All right, so today we are going to start by reviewing how to simplify radicals. And the way we're going to do that is by first reviewing two properties that we've already covered. First, we have the product property, which is, when we hear the word product, we think multiplication. The rule itself is when you have a radical with two different terms, integers, really anything being multiplied by each other. In this situation, it can be broken down into the root of x times the root, I'm gonna dot there, the root of y. And that's all. So an example would be something like if I gave you the square root of 4 times 2, or the square root of 8, because 4 times 2 is 8, but I'm just not going that far yet. I want to exactly copy the format of this rule. If I gave you this example, you would know that you can break this into the square root of 4 times the square root of 2. And luckily, in this situation, this is a perfect square. The square root of 4 is 2. The square root of 2 can't be broken down anymore, so I'm just going to ignore this little dot because we don't need it there anymore. Because when we have two different pieces next to each other, multiplication is implied. And that's my final answer. 2 square root of 2. That is the simplified version. Next up, we have the quotient property, which when we think about quotient, we think about division. So this rule, very similar to the product property, is if you have the root of something divided by something else. This can be broken down into the square root of x divided by your square root of y. So an example of this particular property, we have the square root of 16 divided by 3. And these won't always be perfect squares, but I want to show you how we're going to simplify. So I'm using perfect square examples. Square root of 16 divided by 3. This can be broken down into the square root of 16 divided by the square root of 3. Just like before, when we had the square root of 4 that's a perfect square, the square root of 16 is a perfect square. So I can break this down into 4 divided by the square root of 3. Square root of 16 is 4, all divided by that square root of 3, and that's my final answer. So here we have 4 over the square root of 3. Now we're going to use these properties to simplify radicals even further. So I like to start with writing down a list of my perfect squares. You don't have to do this step if you have them memorized, but I think it's a good place to start because what we're going to want to do is factor these out. Doesn't look like an E. Still doesn't look like an E. All right, so just really quick, I like to write my list of, you could write like 2 squared equals 4, but I just like to write the numbers 4, 9, 16, 25, 36, 49, 64, 81, and let's stop at 100. Because we're just practicing right now, we're not going to do some super complicated examples. And what we're going to do is just jump into some examples. So first, let's do the square root of 75. What we're going to want to do is make this, like create something that we could make fit the product rule, product property, excuse me. So what I'm going to do is factor out the greatest perfect square, so the greatest number from this list that is a factor of 75. I can break this down, but maybe I'm not sure exactly what number I'm going to break it down into. So you might have to do a little guessing and checking. To do this, I'm just going to take my number 75, and let's say maybe I thought 49 is a factor. Let's try it. Divided by 49. Nope, it's not a factor. Then I'm just going to keep moving down my list and keep checking. 75 divided by 36. No. 75 divided by 25. And that is a factor. That is the greatest perfect square that is a factor of 75. So I can break this down, break down my 75 into the square root of 25 times 3. I have not changed this problem. It is the exact same. It's just a different way of writing it. Using my product property, square root of 25 times the square root of 3. Finally, I know what the square root of 25 is. Square root of 25 is 5. 5 times the square root of 3. And we're going to ignore the plus or minus for right now because we really just want to remember how to simplify. That'll come back into play with quadratics. But for right now, your final answer is 5 square root of 3. The next example is going to be a little different. I'm actually going to flip my page over. And this example, number 2, is going to be, what if I gave you the square root of a to the 5th? And that is an exponent if it's not clear. What I want to do in this situation, all it's saying is underneath a radical, I have the square root of a times a times a times a times a. So what I can do is break this up using my exponent properties into something with a radical, or I'm sorry, with an exponent that's a perfect square. So for example, I can break this down into a to the 4th times a. The square root of a to the 4th is going to be a squared. So square root of a to the 4th times the square root of a. Square root of a to the 4th simplifies into a squared. You could think of it as I'm taking the perfect, or the radical, the root of 4. The square root of 4 is going to give me 2 times the square root of a. And that's going to be my final answer. We're not going to work a lot with those, but they will pop up from time to time, so I wanted to show you an example. But one problem that is similar to what we're going to work with, number 3, is something like 4 times the square root of 20. For this example, I'm actually going to kind of ignore that 4 at the beginning to start. So I'm going to pull it off to the side, the little multiplication symbol. And then I'm going to pretend it's not there and move forward just like I would in the past, factoring out the greatest perfect square that is a factor of 20. And I'm thinking of my factors of 20, and my first thought is 2 times 10. But 2 and 10, neither of those are going to be perfect squares, so that's not going to work. So I've got to move on. From there, I'm thinking nothing times 3 gives me 20. Oh, but 4 times 5. 4 is a perfect square. So this can be broken down into the square root of 4 times 5. You don't have to write this step down every time. I'm just doing it because these are the notes. But you could jump right to this step. 4 times the square root of 5 times the square root of 4. And I wrote those in the wrong order for some reason. Square root of 4 and square root of 5 are interchangeable. Bringing it back down, simplifying, 4 is a perfect square, so I have 4 times 2. Super common mistake that I end up seeing is I do think a lot of people just take the radical off and they'll make this 4 times 4. But no, this is 4 times the square root of 4. The square root of 4 is 2 times the square root of 5. And again, I'm sorry I mixed these two up. They should be switched if I was making better notes. Final step, 4 times 2. They are like terms because they're outside of my radical, so I can multiply them. 4 times 2 gives me 8, square root of 5. And that is my final answer for number 3. All right, for our fourth example, this one is very similar to what you're going to see in our quadratics unit. They look complicated at first, but once you notice a couple tricks, they're really easy to simplify. We have 6 square root of 18 divided by 3. We're going to start with this. Sometimes there will probably be a plus or minus, but let's just say this is the most simplified version that we have of an equation, and we're like, oh, I can't have a radical, right? A radical that's that big. So I've got to simplify it. What I'm going to do is ignore the 3 and ignore the 6, and I'm going to focus on that square root of 18. To do that, I'm got to do one thing first, which is I'm noticing right away 6 divided by 3. That's going to give me 2. So I actually have 2 square root of 18. Moving forward, I'm going to go ahead and ignore that 2, focus on my square root of 18. 2 times the square root of 9 times 2. 9 is a perfect square that I factored out. Then I have 2 times the square root of 9 times the square root of 2. 2 times the square root of 9 is 3 times the square root of 2. I combine like terms. 2 times 3 is 6, square root of 2.